Hi everybody. In this short video we're going to discuss three ways for defining a complex number. Let's start with the easy way. That's the Cartesian notation, in which a complex number z is equal to z is x plus j times y. And x is the real part and y is the imaginary part. We can put z in a complex plane in which the horizontal axis is equal to the real axis and the vertical axis is the imaginary axis. And we put z over here. So z is x plus j times y. Okay, now let's draw a vector towards z in this way, and the vector has a length of r and makes an angle of phi with the real axis. So now we can express r and phi in x and y. So we can say r is the square root of the real part squared, x squared, plus the imaginary part squared, y squared. And phi is equal to the arctangent of y over x. So it's arctangent or tangent inverse of y over x, because the tangent of phi is y over x. We can also define the sine of phi. And the sine of phi is y over r. This yields y is r times the sine of phi. We can do the same for the cosine of phi. The cosine of phi is x over r. So x is r times the cosine of phi. So we now have an expression for y and x, and we can substitute that in the notation for z. So we can say z is x, which is r times the cosine of phi, plus j times y, and y was r times the sine of phi, which is equal to r times the cosine of phi plus j times the sine of phi. The third way, the third expression, is the Euler notation, which is z is r times e to the power j phi. So when we compare that with the goniometric expression over here, we can say e to the power j phi is equal to cosine phi plus j times the sine of phi. And why is that Euler notation that easy? That is because in engineering we often use multiplications and divisions of a lot of complex numbers. Let's start with an example. Let's say we have to realize the following complex number, z1 over z2 times z3. When we use the Euler notation, we get r1 times e to the power j phi1 divided by r2 times e to the power j phi2 times r3 times e to the power j phi3, which is r1 over r2 times r3 times e to the power j phi1 minus phi2 minus phi3. And that is because when you have an exponential number with the same base, which is e in the Euler notation, then you may add or subtract the exponents. You may add them when you multiply these complex numbers, and you may subtract them when you have to divide these complex numbers. So it's phi1 in the numerator, so it's phi1 over here, and phi2 and phi3 are in the denominator, so we have to subtract them from phi1. And now we have a new vector with a length of r1 over r2 times r3, and we have a new angle from that factor to the real axis, which is equal to V1 minus V2 minus V3. So this calculating with these kind of complex numbers is much more easier than you should have when you use the normal notation for a complex number, because then you have to do a lot of mathematical operations. So that's why the Euler notation is often used in engineering. Thank you for watching and see you next time.